Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members to our discussion and kindly request us to subscribe and also engage us in the comment section for our further discussion. Now in this specific video, I'm going to look at the group 3 elements. And of course, I said that these are going to be having different designations according to perhaps the text that we're going to come across. Now, in this case, these are going to be given as a group 3A, and then we shall have others giving them as a group 13 given as such. Now, in this particular case, these are going to be classified as the S and P block elements, as I said. And of course, we had mentioned that we are going to categorize these specific elements depending on the, of course, according to the position of the last electrons, which are going to be added, of course, on top of those present, of course, or present in the preceding elements. Now, in this particular case, we had said that the alkali and earth metals and the alkaline earth metals are going to be forming the S block elements. And at this middle section, we're going to have elements which are going to be, of course, having a specific configuration whose last electrons are going to enter the D subshell, and therefore we classified them as or the D subshell in the next to the last shell, and we classified these ones as the D block elements. Now, in this specific part, we had an integral part of this small section of elements we refer to as the lanthanides and actinides series. And this was a third category that, of course, whose electrons are going to be occupying the F subshell in the N-2 shell, which we had mentioned. And of course, this was going to be given a classification of the F block element. Now, in this particular case, of course, this was an integral part of these transition elements, in a sense that this one forms a range of the outer transition metals, whereas this lanthanide and actinide series forms an inner section of the inner transition elements. Now, in this particular case, there's this specific section which I've given in the color code of white, and of course, there are some which have given some slashes in this specific case, which are going to be forming what we refer to as metalloids. And these are going to be semi-conductors or semi-metals. They are going to display both properties of metals and non-metals. And of course, there are going to be a section of metals which are going to be having properties or properties whose specific characteristics is in between metals and non-metals. Now, the group 3 elements, of course, are going to form a range of characteristics. Now, unlike the alkali earth metals and the alkaline earth metals, they are going to display a range of characteristics, and some of them are going to be deviating from the normal trends, which we expect perhaps for a gradual increase or gradual decrease in some of the characteristics, whereby we're going to see that basically some of the measurements are not going to be having a specific trend, and therefore we're going to look at each individual member from that specific group according to perhaps its specific characteristic. Now, in this specific case, of course, we're going to look at these particular members who are boron, aluminium, gallium, indium, thallium, and niobium. And particularly, we're going to emphasize on the first, perhaps the first 5, and try to see what are some of the characteristics. Now, emphasis is going to be this specific element of boron, which is going to display some of the unique properties in this specific class of compounds, as we had seen for the case of beryllium. And I mentioned, of course, about the diagonal properties which are going to be realized in this specific part. Now, in my next display, I'm going to give some of the characteristics in terms of a tabular form, which are going to assist us trying to, of course, check the trend of some of the physical properties of this group 3 elements, ranging from boron to perhaps thallium in that specific order. Now, I've given this specific display so that we can be able to look at the trends for the particular elements, especially for, of course, aluminium. I'd say that we're going to look at boron in its specific, of course, way, in a sense that it's going to display some unique properties. And of course, we're going to look at the range from aluminium, gallium, indium, and of course, thallium, as mentioned. And therefore we are going to look at this specific configuration. So we had said that these are going to form the valence electrons, as we're going to see, and of course this is going to be given in this specific order using the short hand form of noble elements. Now we had said, of course, that we are going to see also the trend for the ionic and atomic radii. Now, so you can see from this one, there's a specific way in which these elements are going to be having this particular increase, but there's a unique case for gallium, especially at this specific point. So that's why I mentioned that basically we're going to witness some abnormalities in that trends, which are not going to be a generally gradual or decrease or increase as we have said. And of course, we're going to look at this specific point. Now, for the ionic radii, this is going to be increasing. And then, of course, for the general increase, which you had mentioned, especially for the group 1 and 2 elements, that was due to increase in the number of energy levels, which of course resulted in the shielding effect. And of course, this is going to be having a net effect of increase in the atomic and ionic radii in that particular case. Now, for the electronegativity, this is going to be having a positive trend. And of course, this is going to be realized due to this specific nature of increase, as well as we had said in the number of energy levels. Now, the ionization energy as well is going to be having a specific trend, but of course, we're going to see that there's an abnormality in indium having this specific, of course, characteristic. Now, we had said that basically the ionization energy is the amount of energy required to remove an electron from the outermost energy level. And in case it is going to be increasing, then it's going to be, of course, due to the strong attraction forces from the nucleus. And of course, in case it's going to decrease, then it's going to be due to, of course, electrons being further away from the nucleus in that specific order. Now, for the standard electrode potential, this is going to be relatively a smaller negative value as we compare to the group 1 and group 2 elements. And they would say that for elements which are going to display a larger negative value for ionization energy, that is going to be out of the standard electrode potential. That is going to be basically due to the fact of increase in metallic character. Now, in this specific point as well, we can see that the melting and boiling points are going to be having some kind of abnormality in some cases. But for this one, this is going to be having a general trend of decreasing for the boiling points. And as we said, of course, the effect of the shielding effect and an increase in energy levels is going to have an effect on the amount of attractive forces being experienced by the outer energy levels in that specific case. Now, the increase in density is due to the mass and volume, increase in mass and volume ratio. And of course, we had mentioned that one from our previous discussion. Now, there's going to be general decrease in hardness, and this specific aspect of conductivity is not going to have a generally defined trend, as we can see from this specific table. Now, in our next discussion, as I had promised, we are going to look at the individual characteristics of these specific elements. And I promised that we're going to basically create an emphasis on this particular element of boron and try to see how it's going to be displaying some unique properties. And we had said that, of course, of the diagonal characteristics or diagonal relationship of some of the elements in the periodic table. And we're going to see whether it's going to display some of the diagonal relationship, just like barium, which of course close relationship, whose products had a close relationship with aluminium. And of course, as we are going to see that boron as well is going to be, we are going to check out whether it's going to be displaying some of the properties which are going to be displayed by these specific products of silicon. Now, I'd kindly like to request our members to check our description boxes. They are going to contain links of other similar videos which are going to complement on our various discussions. So that is it for now, guys. By God bless you. Catch us in our next video.